In this video tutorial, we'll use Sentinel-1 data for agricultural monitoring. Using a large time series of 25 images acquired throughout 1 year, we will see how the temporal backscatter changes for different types of crop. For this tutorial, we're going to use subsets. Given that we have a very long time series, the processing will be much faster if we work with subset images. I will open these images in Snap. These images have been subsetted prior to this exercise, and that was done by using the raster subset function. Here you can specify a subset by geographic coordinates. So these images were acquired throughout 2016. Rather than processing each image individually, we're going to use the batch processing function of Snap. We will also use the graph processing function, which enables us to create a processing chain. We go to Tools, Graph Builder, and here we can specify our processing chain. First we will do a calibration. So we go to radiometric calibration. Then we will apply, by the way, to create a process, you right click with the mouse, select Add, and here you can select a process. So now we will include speckle filtering. Then we will do terrain correction. Radar geometric terrain correction. And finally, we'll do a conversion to dB. Raster data conversion linear to from dB. Now we need to connect these various processes. You can do that by hovering the mouse icon at the edge of each process until the red arrow appears, and then clicking and dragging to the next process. So we had calibration, then speckle filter, then terrain correction, linear to dB, and finally writing an output image. We can modify the parameters of each of these processes by clicking on each one. We'll leave most as default. We'll only make a few changes. So the speckle filtering will select a Lee filter. The terrain correction we can leave all as default. Linear to from dB, and write. Now it's important to note at this stage that we do not run this processing chain on a single image. What we want to do is run this processing chain on the entire batch. So first we need to save this processing chain by clicking on Save, and we will call this Agriculture Graph. Now we close this window and we select Tools, Batch Processing, and here we can select this icon to add all the open products in the list to be batch processed. And then we load the processing chain to be applied on all of these images. And here you see along the top the different tabs corresponding to each process in the processing chain. Now we can specify an output folder, and we can select Run. The process may take some time, given that it's applying various different processes to an entire batch. But at this point you can go and take a coffee, or you can do something else while the process is running. When the process finishes, it opens all of the output images in the Product Explorer window. However, the output file name is the same as the input file name. So here we'll have 25 duplicated images, so we'll have 50 images in total. At this point, the easiest thing to do is to close all of the images. So select Close All Products, and then open only the output images. This way we are sure to have only the output images open in the viewer. What we will do now is to stack these images together into one file with which we can look at different RGB combinations. We go to Radar, Co-registration, Stack Tools, Create Stack. And here we can add all of the images open. In the Create Stack tab, here we select Product Geolocation as the initial offset method. Here we have not updated the orbit information of the products, but the product geolocation is accurate enough for our purposes. For the output, we can rename the file, keeping only the common parts of the file name, which are common to all the 25 images. And then here we can select Run. Now we can look at some RGB composites of this time series. For example, we can look at a polarimetric composite of images of the same date. So, for example, we can select VV of the first image acquisition on the 12th of January. We can assign the VV channel to red, the VH channel to green, and for blue we can assign the difference between the VH and the VV. And this is what we get. Another RGB composite we could do is to look at images of the same polarization but for different dates. So again, we go to Window, open RGB Image window, and here, for example, we could select only the VH channel, but of images acquired every 4 months. We have 3 channels, so if we assign images acquired every 4 months, then we have an even distribution throughout the year. So the first image can be January, the second one can be May, and then for the blue channel we can assign the VH image acquired in September, in the beginning of September. And here we have a very colourful RGB composite of images acquired on different dates. What we will do now is to look at some fields where we know the crop type. And we have some shape files which we will overlay onto these fields. So we can open these shape files by going to the Layer Manager and selecting the plus icon selecting ESRI shapefile and browsing to where we have our shapefiles. So here we have a field boundary of crops corresponding to these different crop types. We can do that for all of the shapefiles that we have. Sorry, I cancelled that one by accident. So here we have fields of known crop types. And we will look at the backscatter signature over time, not just for these 3 dates of this RGB composite, but of the entire time series. We can do that by going to View, Tool Windows, Radar, Time Series. In the settings, we can insert all of the products we have open minus the stack image. This function works with individual images, not with the stack. So we remove the stack from the list and then we click on Apply. Then we can close this window. And if we select the filter, then here we can select which channel we wish to view. For example, if you want to see the VH backscatter over time, then we select that and then click on OK. And here we can see the temporal backscatter throughout the entire time series for every pixel on the image. And as we move the mouse cursor over the image, as the mouse cursor hits a particular pixel, we can see the backscatter signature over time of that pixel. What we will now do is to compare the backscatter of individual pixels. So first we need to select those pixels, and we do that by going to View, Tool Windows, Pin Manager. We can place pins over particular fields. For example, we can start with the potato field. We can place a pin over this field and we can rename this pin potato. Then we can place a pixel over the spring wheat field and call this spring wheat. We can also change the color here. Sugar beet. Let's make this red. Winter barley. In fact, let's make this a different color. And then winter wheat. And we can make this maybe green. And now if we select this icon here, show for all pins, then here we can see the backscatter signature of all the pins compared in the same plot. What's interesting to note is that the signature is the same for some periods of the year, but for other periods there's quite a big difference in the backscatter of the different crop types. The backscatter signature over time varies considerably over different areas, so it may not be possible to derive a unique backscatter signature that's valid for the same crop in all areas. However, this at least gives you an indication of the differences in backscatter for different crops over time. I hope you enjoyed the tutorial, and thank you for watching.